In the dramatic sweeping landscapes of southwest China, where the mighty Jinsha River carves its path between Sichuan and Yunnan provinces, a new colossus of human engineering has risen. This is the Baihetan Dam, a structure of breathtaking scale and ambition that stands as a testament to modern technological prowess. Completed in late 2022, this colossal arch dam towers 289 meters high, holding back a vast reservoir of over 20 billion cubic meters of water. It is a monumental achievement, second in global hydropower capacity only to its famous sibling, the Three Gorges Dam, which lies further downstream on the same river system, the Yangtze. Baihetan represents the next chapter in China's quest for clean energy on an immense scale. The primary purpose of this megastructure is to generate astonishing amounts of electricity. Inside its cavernous powerhouse, 16 enormous turbines, each with a world-leading capacity of 1 gigawatt, spin relentlessly. Together, they can produce 16,000 megawatts of power, generating enough clean electricity each year to meet the needs of roughly 75 million people. This output is a critical component of China's strategy to reduce its reliance on coal and move towards its goal of carbon neutrality. Beyond power generation, the dam plays a vital role in taming the river's often destructive floods, offering greater protection to the millions of people who live in the downstream floodplains, a benefit that cannot be overstated in this historically vulnerable region. When we compare Baihetan to its predecessor, the Three Gorges Dam, we see both similarities and a clear evolution in engineering. Both are designed to harness the immense power of the Yangtze River system for electricity and flood management. However, Baihetan, built decades later, benefits from significant technological advancements. Its turbines are more powerful and efficient, and the design of its double curvature arch dam is considered a masterpiece of hydraulic engineering. This newer project, while still vast, was also built in a less densely populated area, which had a profound impact on one of the most challenging aspects of these projects, the human cost of resettlement. The construction of such a monumental dam is a multifaceted endeavor with far-reaching consequences. It serves as a powerful tool in the fight against climate change by providing a reliable source of renewable energy. Its ability to regulate water flow also enhances navigation on the river and provides a more stable water supply for agriculture and cities. Yet, this incredible power is not without its complexities. The creation of the vast reservoir required the inundation of thousands of hectares of farmland and forests, forever altering the local landscape and the lives of the communities that called that land home. A story common to mega projects the world over. It is a truly remarkable thought that a structure built by human hands could have an effect, however small, on the movement of our entire planet. The idea that mega dams like Baihetan can alter the Earth's rotation is not science fiction. It is based on a fundamental principle of physics known as the conservation of angular momentum. Imagine a figure skater spinning on the ice. When she pulls her arms in, she spins faster. When she extends her arms out, her spin slows down. Our planet operates on the same principle. By building a dam and filling its reservoir, we are effectively moving a colossal weight of water, trillions of kilograms, from the oceans to a higher elevation on land, slightly farther from the Earth's axis of rotation. This redistribution of mass is like the skater extending her arms. It minutely increases the Earth's moment of inertia, which is a measure of how spread out its mass is. To conserve angular momentum, this tiny increase in inertia must be balanced by an equally tiny decrease in the planet's rotational speed. Consequently, the length of our day becomes infinitesimally longer. For the larger Three Gorges Dam, NASA scientists calculated that the filling of its reservoir increased the length of a day by a mere 0.06 microseconds. That is 60 millionths of a second, a duration so vanishingly small that it is utterly imperceptible in our daily and requires atomic clocks to even detect. The effect of Baihetan with its smaller reservoir is even less than that of the Three Gorges. Furthermore, this mass shift also causes a tiny wobble in the Earth's axis, causing the geographic poles to drift by a few centimeters. While scientifically fascinating, this effect is completely dwarfed by natural phenomena. Massive ocean currents, atmospheric pressure changes, and the slow movement of molten rock deep within the Earth's mantle have a vastly greater impact on our planet's spin. Even a single major earthquake like the one in Sumatra in 2004 can redistribute enough mass to shorten the day by several microseconds, far more than any dam ever could. So while it is true that these engineering marvels leave a faint fingerprint on our planet's celestial dance, the impact is of purely academic interest. It serves as a profound reminder of the scale on which we are now operating, but it poses no practical risk to our world. The true and most significant impacts of these dams are not felt in the heavens, but right here on the ground. They are measured not in microseconds, but in the tangible changes to ecosystems, landscapes, and the lives of the people and animals who depend on the river for their existence. Comparing the Baihetan Dam to the older Three Gorges Dam is like comparing two generations of giants. Both are born from the same ambition to master the Yangtze River, yet they reflect different eras of technology and social awareness. The Three Gorges Dam, completed in 2012, remains the undisputed king of hydropower. With an installed capacity of 22,500 megawatts and a reservoir that holds a staggering 39 billion cubic meters of water. Baihetan, though the world's second largest, is smaller, with a 16,000 megawatt capacity. This difference in scale is immediately apparent, yet Baihetan's design incorporates lessons learned from its larger predecessor, making it in some ways a more refined and efficient machine. One of the most significant differences lies in the human impact of their construction, particularly concerning resettlement. The creation of the Three Gorges Reservoir was an event of historic proportions, requiring the relocation of over 1.3 million people from cities and villages that were submerged forever. It was a monumental social challenge with long-lasting consequences. Baihetan, situated further upstream in a more rugged and less populated region, required the displacement of a significantly smaller number of people, estimated to be between 80,000 and 100,000. While this is still a profound disruption for those communities, the scale of the social upheaval was comparatively less immense than that of the Three Gorges project. Technologically, Baihetan represents a leap forward. It boasts the world's first ever set of 1 gigawatt generating units, pushing the boundaries of turbine design and manufacturing. These machines are not only more powerful, but also operate with greater stability and efficiency, a result of decades of accumulated knowledge in hydropower engineering. The dam's elegant double curvature arch design is also considered a more advanced and materially efficient solution for the narrow, steep-sided gorge in which it is located, contrasting with the massive gravity dam design of the Three Gorges. This reflects a continuous refinement of engineering practices over time. However, both titans share a common set of environmental and geological concerns. Both dams are built in seismically active regions, raising the risk of reservoir-induced seismicity, where the immense weight of the water in the reservoir can put pressure on underlying rock formations and potentially trigger small earthquakes. They also fundamentally alter the river's natural rhythm. By trapping silt and sediment that would otherwise flow downstream to enrich floodplains and coastal deltas, they change the very chemistry and morphology of the river for hundreds of kilometers, a challenge that engineering has yet to fully solve for any megadam. While the notion of a dam slowing the Earth's spin captivates the imagination, the scientific consensus is clear. The effect is real but entirely negligible. The true weight of these megadams is measured in their direct, tangible impacts on the environment and human societies. Experts urge us to focus our attention here, where the stakes are highest. The construction of Baihetan, like all dams, has permanently altered the river's ecosystem. The natural flow of water is now regulated by human command, which disrupts the life cycles of countless aquatic species, especially migratory fish, whose ancient spawning routes are now blocked by an impassable wall of concrete. The dam also acts as a giant sediment trap. The nutrient-rich silt that once flowed freely down the Jinsha and Yangtze rivers, nourishing downstream ecosystems and replenishing the delta near Shanghai, is now accumulating at the bottom of the reservoir. This river starvation can lead to erosion of the riverbanks and coastline downstream, affecting agriculture and wetlands. Furthermore, the slow-moving water in the vast reservoir can suffer from a lack of oxygen, potentially creating dead zones and releasing greenhouse gases like methane, an ironic side effect for a project designed to produce clean energy. These are profound and lasting ecological transformations. Beyond the environmental toll, the social cost remains a central concern. For the tens of thousands of people resettled for the Baihetan project, the dam represents an irreversible upheaval. Entire villages, ancestral homes, and fertile farmland were submerged beneath the rising waters. While the government provides compensation and new housing, the transition is often fraught with difficulty. Rebuilding livelihoods, adapting to new environments, and preserving cultural identity are immense challenges. Studies show that while economic benefits like new infrastructure eventually arrive, the initial social welfare of displaced communities often declines for years due to the stress and disruption of relocation. In the final analysis, experts view megadams like Baihetan through a lens of complex trade-offs. They are undeniably powerful tools in providing clean energy and controlling devastating floods, contributing significantly to regional economic development and national climate goals. Yet, this progress comes at a great cost to local ecosystems and communities. The most important conversation is not about planetary physics, but about finding a more sustainable balance. It is about ensuring that the benefits are shared equitably and that we do everything in our power to mitigate the damage to the natural world and protect the dignity and well-being of the people whose lives are most directly affected by these modern marvels.